All right, so where are we going with this one? Well, I was thinking about a lot of things yesterday, or last night actually. This one I've blocked out, you can't see it, can you? No, it's okay if you can't, it's good. So a lot of things about, yeah, so there's three subjects on this board. This one, not yet. I was thinking about cells, right?
Yeah.
Single cells, we were talking yesterday. The missing link with, is it biology?
Yeah.
Is what sticks them together. Yes? What holds it all together.
Yeah.
Which seems to be this anti stuff, doesn't it? The reverse of everything.
Yeah.
That's as far as I can look at it. Because I was looking at where did life forms come from, single cells, bacterium, blah, blah, blah. And then onto more advanced sort of stuff, let's say, where it all comes together. But the glue part is missing. The glue. And I think the glue is the dark part that becomes revealed when you look. Is it an atom, where you see the atoms? And when you see the physical, there's often something that's missing that appears to be invisible, but it reveals itself through the visible. Then you see the invisible. Now it's very interesting. So I'll probably get onto that one at a later date, and not right now.
Okay.
And then I was thinking about planets, is where I'm at the moment. Meteorites and planets, kind of strange. I see it as like comets with tails, yes?
Yeah.
I know it seems a bit weird, but it often reminds me of sperm with eggs.
Yeah.
Yes?
Mm-hmm.
Do you get what I mean? With the comet tail goes into the planet being the egg.
Yeah.
And it's not far from that, to be honest, because if you think about it, it then seeds the planet. Which is very interesting. I must admit, so, got all of this here. I've just mess-assing around with it, to be honest. So I'm just memorizing as we go, because I've got to wipe it off. And that's as far as I got. And I'm going to continue it now, I think. The other one I'm going to get onto a bit later. And this one's very interesting. I don't know if I want to wipe that just yet. It's not distracting, is it?
I can barely see it.
That's good. That's what you're meant to not be able to see it.
Mm-hmm.
Let's give that a little wipe. Wait.
Squeaky clean.
Pull that. Bit of wipe. Right, there we are. Good. So, what I was trying to calculate, and there was a lot of things I was thinking about, because follow on from yesterday. It never really left. You can look at our moon in very two different ways, yeah?
Yeah.
I think if you dig down on the moon, you're gonna find, I think, old life forms.
Yeah.
Yeah. I think it's just hidden under a lot of micro impacts. And I think the moon was liquid once.
Yeah.
I think it had an atmosphere much like Earth's. Not as big, not as grandy. And deserts. Deserts are always hot, yes? Is it always places where you've got a lot of sand content are always hotter?
Sand and stones, yeah.
More so sand, yeah?
Yeah.
Because sand is like little tiny beads of like magnifying glass, yeah? Then that's not heating anything up at all. You see, that's where I was sort of getting with that. It was like, what makes the atmosphere on Mars? I just couldn't piece it together. Like, it's got no internal heat source. It receives heat from the star, but is it enough? And if we've got something that's covered in ice, often or not, it usually scatters the light, the rays, the heat.
Yep.
When I was thinking about Mars, why does it hold on to so much heat? But it's full of sand. And sand acts like a magnifying glass, doesn't it?
Yeah.
And when it gets warm, it holds on to it pretty well. So, sand being tiny bits of glass, technically, it's not, but it's similar too. And it sparkles, doesn't it? So, if you can hold a magnifying glass quite high up and get it at the right angle, and sand is so hit and miss, isn't it, that it can capture the light and throw it in many different directions. And therefore, can it be making very small, although very small, it's going to be amplifying the light, therefore heat, like magnifying glass.
Yeah.
After all, when we combine sand and we purify it and make a super cooled liquid, or as crystal, we can often increase the heat with it. And likewise, we can also bounce the heat away. So you can make an object really hot, and you can make an object cool down as well by scattering the light. So not only does it attract light, it's very reciprocal, really, isn't it? You can use glass to shade, and you can also use glass to increase the heat, increase the light, concentrate it. So I was thinking about that, and that's in a big format, right?
Yeah.
So obviously, if it's in a bigger format, it intensifies the heat. But if it's in a smaller format, it's still generating this heat, but less. But large amounts of it, it must be creating more. Yeah, I don't know. It was kind of weird about that. I was weirding out about it because I couldn't understand how, and then there's planets that they can't make go away in the model. Some particular scientist was playing around with modeling, and the model keeps falling apart when they're looking at the bigger planets towards the end. And I was sitting there thinking to myself, then they didn't form that way. They got bigger later. They were smaller in the beginning. And again, just because the gas giant looks big, we haven't actually found a stone giant. A planet made of fucking sheer colossal... There isn't one, is there? They are differentiating in sizes, but it's the atmosphere that's different.
Yeah.
Well, we noticed that. Then we could say to Uranus, Neptune, and all of that. But that's gas, though. Further away from the star, right? And again, it seems to be reflecting a lot more light, so therefore it would explain why it's colder and some are more hotter. But again, if it gets any bigger, it's going to start heating up. Then that ice is going to turn into a gas and puff out. So, I don't think the universe, the way we believe it to be, is the way it's said. I'm going to throw an ore in. I like ores. You can roll with them. So, when we understand sand or glass, right? On the small scale, it must do what it's doing on the big scale. Right, there's two things that it's doing. One is it can bounce light off of it, yes, and therefore heat. But it can also allow more concentrated light to come in and therefore create more heat, which is more concentrated, but still create more versus small amount. And that's when it's rather large. So if I were to take a magnifying glass and I can shade with it, and I can also alter the angle, and I can create a scorch mark, make it hotter. So if I were to smash that up into a load of little pieces, that must still be doing it, depending on the angle and depending on the light that's coming in. So therefore, would that make why most deserts are really hot? Because of the sand. If we were to cover the sand, really weird experiment, but still, if we were to put loads of, I don't know, just cover the sand, would it cool down? Or if we were to angle all the pieces of sand, let's say, to, because it's very sparkly, isn't it? It's very crystally is the right word. And again, you don't really notice it. The eyes are tuned between one versus the other. And when you've got a lot of it together and you start, even some of that stuff that I was making, wow, that was beautiful. But it still had the same process. I just wanted to see if I could make glass and actually get water inside it. And yeah, you can. It's kind of weird. That's kind of weird, isn't it? I wanted to see if I could make glass and get water in it. And keep the water in it. And it worked. I couldn't believe that. So anyway, never mind. That boggled my mind a little bit. I just wanted to see if it was possible to put water inside molten glass. Never mind. Anyway. And yes, you can. That's fucking weird. And so when collecting sand, we can magnify the light. So, the moon's temperature swings from hot and cold, but it does have tiny pieces of Regorworth in it. Hence why we see it. It's really reflective. So, without the moon, we would be colder than what we are. And some people say that the moon causes us to get colder. It removes... I'm not sure. If it's bouncing off some level of light, sure, not as hot. But when you notice the halo, that's when you really see it, though, don't you?
Yeah.
You remember seeing that halo?
Yeah, I remember that.
It was very beautiful, wasn't it?
Hmm.
But wouldn't you say you feel warmer in the moonlight? As opposed to when you don't see the moon, it just feels a bit colder to me. Not by much, it's slight. I don't know, some people did some tests with it and found that it was colder in the moonlight, but I don't know. I'm not sure. I think that's bouncing a lot. Yes, a lot of the heat is going into this object, don't get me wrong, but if it's bouncing light, it's got to be bouncing heat.
Hmm.
Yeah, I don't understand thermal radiation very well. Yeah, I just think it's all very different, isn't it? Yeah, I'm going to throw in an ore. I'm going to throw in an ore. Certain objects that when I'm bouncing light using a mirror, the back of the mirror gets really hot. When I'm using a magnifying glass to alter the beam, let's say, the glass itself doesn't get hot. That's interesting, isn't it? So if I'm using a mirror, the back of the mirror gets really, really hot.
Hmm.
But when I'm using a magnifying glass, it does not. And I try and look at that, what's the moon? The moon has got a back to it. So what's it absorbing? It's absorbing more heat from that. But not all of it.
Hmm.
Because it's got beads. Now, depending on which way they're chewing the light off, although it's very small, minute. Light, heat, cold. Interesting. Still very interesting. Do you think we're receiving minute amounts of heat from all the other stars? As well as the main star is the dominant one. But if we were to lose that, do you think we get heat from the stars?
I don't think we would, but there might be something coming, but it wouldn't be probably enough, would it?
Well, it's interesting you should say that, because space itself technically doesn't get hot.
Yeah.
It's only when the light hits an object that it gets hot. It's interesting, isn't it?
Yeah.
So, is the glass trapping a lot of this? I've never looked at glass through an atomic microscope before, but it would be very interesting to see whether the glass is actually transparent or it's collected a lot of the dark energy, if we want to call it that.
Yeah.
And it's gathered some of that, and that is what is sort of magnifying light. See, again, it's very interesting, right? Space itself is not very hot. How do you measure the temperature of space? Because as soon as you put something out to measure it, the particles are going to interact with that and then cause a temperature spike. But that's a false positive, though, isn't it? How do you test how cold space is in the beam? Do you get what I mean by that? And
Yes,
it's almost
I
like
do.
it travels from point A, being the star, yes, to point B, and the intensity seems to be here, but I'm not seeing it. Because if not, I would see the heat coming like this, wouldn't I?
Yeah.
So it's not radiating into space, yes? So it seems to be a lot colder. Interesting. Interesting. Because if it was doing that, would we get any heat at all? Because there's X amount of space from here to here. Would we be hotter? Probably not. So it's not influencing with anything that's until it hits. So light only influences matter. And space has no matter in it. Black holes influence that matter, the stuff that we can't see, as well as the stuff we can see. But is it diffusing in a way that, let's look at it this way. So we've got matter, and then let's just call it antimatter, yes? And then matter, antimatter. And then we'll have antimatter, and then matter, antimatter. So it's reverse, yes?
Okay.
So beams, stars, hit this stuff and cause it to get hot.
Yeah.
But it doesn't seem to respond to this stuff here. So does it travel through this stuff that's in us and react with the matter, let's say, for argument's sake?
Yeah.
And black holes, do they influence this stuff, which pulls apart this, the object itself? So therefore, are black holes reacting to the stuff that we can't see and pulling this? And if there is, because we can't see it, what's the speed of that? So the speed of light is the fastest, let's say, yeah? But what if we can't see this, and this affects black holes, and black holes are pulling this stuff towards it? What's that speed? If light can't escape a black hole, yes, the star gets into it. It can orbit around for a bit, but it, slowly but surely, I believe that but you won't be able to see it. It's interesting. The star that's orbiting is being siphoned off, bit by bit, until it gives out and... But what's it pulling? And then does the star have a lot of this? To be able to see a star in the atomic ratio, yes? Then we'd see the atoms, yes? Or the atom ratio. Is it made up of this stuff? And is it squashing two of these together? And not only is it making hydrogen into helium and X, Y, Z, yes, we're not going to sit here and draw the whole periodic table twice. But when is it squashing two of these together? And then once that's released, that is a certain element. Two of these, which is then making me think about the bacteria. How does it mutate if it's single? What if it's binding with something but we can't see it? Much like this. So we've got, what do we say? Periodic table, and we'll say this is the plus, yes? And we've got periodic table, and this is a minus. But do we have a third? That when you take one of these and smash it together, that's the element that you're creating. Because on its own, it would be hydrogen. On its own, it would be dark energy, let's say. Yes, or antimatter, whatever you want to call it. But if you combine this with this, you get this. If you combine this one with this one, you get this. Then you get this, then you get this, then you get this, then you get this. And then are black holes then reversing this process? It takes this and this to then make this and this. Which then creates the instability, which is needed in order to create the cycle over again and again and again. I was often wondering about this because it seems that light does not react with a black hole. And it doesn't react with the space of traveling through from one to the other. Until it hits an object. Then it heats it. But if there's X amount of distance from star to here, being this invisible stuff, and it could interact with it, we would never feel heat. Because it would have been exhausted. In fact, the stars would never produce any heat. That's where I'm thinking with that. Now, whether you choose to understand that or not, or believe that or not, but I don't know. I think there's a plus and a minus. And then when I was thinking about cells, what holds it together? And then if you can understand, if you've got this and this, you've got this element. If you've got this, this, and this, and this, you've got this element. Which then stops me from walking through objects and stops objects from walking through me. Although it's got empty gaps in it, I should be able to pass through it, shouldn't I? Technically. But you don't. Now, what is that force that stops you from, so that I can hold something? So that my organs don't squash into each other? So that I don't bleed out, essentially. Because there must be a difference between this layer and the next layer and the next layer. But with so many empty gaps in between, you would think that it would find its way through, wouldn't you? But it doesn't. And then you would think that it would all merge together. It would all be stuck together like a blob. That's what we would be, just nothing but a blob. But we're not. There's a layer of skin that we can remove, muscle we can remove, bone, and it's all separate and it all remembers what it is.
Yeah.
And then what's being pulled from the star? Is the star pushing light out, or does it have these little elements of antimatter at the right ratio that the darkness is pulling? The black hole essentially is pulling out. But the mass together is trying to pull back. Tug of war, which then causes the stretching and squeezing, but it's far more when you get to a certain size. Is that force more, which is like essentially bending metal together? And it's this pull and push that is squashing these things together, which then creates these two that then create this. And it's the bacteria or the cells doing the same thing. And that's what causes a mutation. Create something new. Create something new. And then it knows which one to stick to what to come together and make up a body. No, we've got trillions of different parts, but the missing ingredient is the glue, right?
Yeah.
We're all being stuck together, and you could say pressure. I also noticed this with astronauts. They look puffy when they're in space. And also the cosmonaut, don't remember the name, where they did the first spacewalk, wasn't it? And it started to inflate. They looked like Michelin.
Yeah.
Well, is that pressure doing that because it's overinflating, or that darkness that we associate as being nothing is remnants of a black hole, technically, that is trying to pull things? And then what pulls the comet tail? It's always one direction, right? Well, is it that the sun is heating that up, or is something pulling it? Is the solar sail traveling because the sunlight is hitting it, or does it have certain blackness in it, the antimatter, and it's pulling on that, and that takes time to get up to speed? Because remember, you would never be able to know which one it truly is, would you?
No.
You could only assume that it's a sail working because of the light, or is something pulling it? Interesting. Anyway, never mind, because that one is a bit different when they do it on Earth. They show you this moving around, but still, when it comes into space, I don't know. Speed of light, what's the speed of darkness? If light cannot escape a black hole, the speed of darkness must be twice the speed of light. It must be, because if not, the light would be able to escape that, right?
Yeah.
What was it traveling? 186,000 miles per second, yes?
Yeah.
So times 2 it. Got this wrote down somewhere. Somewhere else. It was passing around with that. Shall I go and get it? Save me a whole lot of time.
Yeah.
I'm going to go and get it.
Yeah.
So 186 miles per second, yes? 186,000 miles per second, yes? And times 2 it, it makes it, I think, 384. And 3 zeros on the end of that too, so... Now the speed of light is quite easy to deal with, isn't it? Because you can get a rough gauge of that, right? You can see it, yeah? Then it made me think about eyes. Like there was an experiment that they did when no one looked at it responded, and then when someone looks at it, the observer effect, I think that's because our eyes pull it. I think we've got remnants of darkness in the eye. parts of, I don't know, you want to call it antimatter, you want to call it black hole, what do you want to call it? Dark energy, spooky energy, call it whatever you want.
Yeah.
Either or, that must be pulling something in.
Mm-hmm.
I don't know, kind of weird. And then what, to combine them both together, that's a whopping speed, right? So you'll say that the speed of light, speed of dark, that's 570,000 miles per second.
Mm.
Jesus Christ. Can you imagine going that fast?
Yeah.
That would be interesting, wouldn't it?
Mm.
And then what causes the stars to spin? What's causing the stretch and squeezing that's needed for that heat? We notice it with moons, right?
Yeah.
So moons that orbit a planet, yeah?
Mm-hmm.
They essentially, especially when you look at Io, and I think the Voyager is, told us that we should be looking at textbooks a bit more.
Yeah.
They need rewriting, don't they?
Mm.
It's no good believing something just because the furniture looks good, I think that this one, yes, I think it's correct. Einstein was absolutely right by that, let's say. But I think that when we have then a progression of Stephen Hawking's, right?
Yeah.
That black holes' force is so strong that not even light can escape.
Mm-hmm.
I don't know, then that would be a speed. I always said it, if you could go times 2 the speed of light, twice the speed of light, and you could get ahead of when Earth, so if Earth has been around for 4.5 billion years, let's say, for argument's sake, yes?
Yeah.
So let's say 4.5 billion years on a graph looks like this.
Yeah.
And it's still progressing naturally, yes?
Mm-hmm.
So think of all the TV signals and radio transmissions, the very first ones that ever got sent. That would reach you to a point of here, and every second that is moving and moving, yes?
Yeah.
If you could go times 2 the speed of light, which is roughly about this speed,
Mm-hmm.
it would take half the time to reach here.
Yeah.
And if you had an instrument that could pick up the signal, you would be able to see the first radio and TV transmissions.
Mm-hmm.
All the stuff that was never recorded, let's say.
Yeah.
And then you'd be able to record it now. Yeah, that would be interesting. But there's a little bit more that's interesting on that. You could see your ancestors. Now again, that one sounds like science fiction, right? But your ancestors next to a star, yes?
Mm-hmm.
That travelled out light. And they would silhouette. Atmosphere shatters the light, bounces the light. Then you should be able to see Earth
Mm-hmm.
when it was here.
Yeah.
In fact, you'd be able to see when the solar system was in its nebula.
Yeah.
Because, if we look at certain stars that are so far away, they're no longer living.
Mm-hmm.
Because we're still waiting for that to reach us, and it hasn't reached us yet. It's already dead. It's long gone. It's a remnant. So when you factor that into your calculations, like a piece of string, it works better if you use a piece of string. So we're seeing the star alive here, but it exploded from this part of the USB.
Yeah.
This bit we're seeing now.
Mm-hmm.
So if you hold that, pull it tight, and as you might need to come over here a bit more, that's it, good. And as it comes closer to you, so you're seeing this point now, and as every year that goes by, it's already exploded, but it's got to take time for that signal to get to you, yes?
Yeah.
And then slowly but surely, boom, you see it explode, and then you see nothing afterwards.
Mm-hmm.
Lights go out.
Yeah.
Now, that's interesting to think about that.
Mm-hmm.
Now, you would think that that's over. Now, if I went times 2 the speed of light,
Yeah.
I could come back here and see that star. If I went even further than that, then I'd be able to see before the star even existed.
Mm-hmm. Yeah.
Then I'd be able to look back in time. Now, isn't that eerie?
Yeah, it is here.
That you travel in light.
Yeah.
Now, if there is ET, intelligent life, You know, life forms would be about who dumbs themselves down. Well, you can have some life forms that don't want to admit it. You'll have some life forms that do want to admit it. You'll have some life forms that, as they admit it, they're already building a technology to do this.
Yeah.
And then, would you be able to see them traveling at that speed? If I could make a star move times 2 the speed of light,
Mm-hmm.
would you see it? Often we look at whether we traveled the speed of light, we would not be able to see anything. You know that?
Yeah.
It distorts what you can see, yes?
Yeah.
The faster you go, so think about it, race car goes by at 20 miles an hour. Well, you get to take on a lot of detail on that car at 20 miles an hour.
Yeah.
Now let's see it go past at 100 miles an hour. Now let's see it go past at 1,000 miles an hour. Tell me any logos you see on it. So you wouldn't be able to see it at 1,000 miles an hour, so you miss out a lot of detail, yeah?
Yeah.
So if you saw it at 30 miles an hour, you'd be able to pick out the logos, the sponsors, the brands, what color it is, if it had petrol cap, if it said diesel on there or not, the tires. But at 1,000 miles an hour, would you even know it was a car?
No, probably not.
Now let's say 100,000 miles an hour.
Mm.
The brain stops observing after a while.
Yeah.
It can only see a certain amount in a bandwidth. We can only see so much. So light travels so fast, do you see it?
No.
It appears invisible, right?
Yeah.
But if we were going at the speed of light, or if we were slower, would we be able to see the light?
Yeah.
See, this is the question, right? Which end of the spectrum does it fall on? So the faster an object travels, the less likely you're able to see it. So would you be able to see if something was gobbled up by a black hole? If it did it that quick?
No.
That would be interesting, wouldn't it?
Yeah.
So let's say we can travel at that speed, twice that speed. You would never be able to see it. Then I'm wondering, if something is traveling at that speed, could it travel through a star without noticing it? And here's the next bit. So traveling at that speed, at a certain ratio of being that fast, could you pass through a star? Well, what happens if I take a flame and I run my hands slowly through it? I get burnt quite a bit.
Yeah.
What happens if I do it a little bit faster?
It's less
I don't
or
get
none.
burnt.
Yeah.
If I do it really quick, I barely get burnt. I noticed some people doing this at steel mills, by the way. They were tipping out molten steel,
Yeah.
and someone took their glove off and whacked their hand through it,
Yeah.
and they didn't get burnt. Now, if they'd have done it slower,
Yeah.
it wouldn't be much left.
Yeah.
So if you're traveling pretty quick through molten objects, the faster you travel, would it even register you in reality to be able to do anything to you? And therefore, stars are limited to a speed then, aren't they? They can only fuse if things are jostling slowly. But if it's going too quick, it doesn't work because it can't register it. It's too quick. So you understand that stars have a life speed as well and a time warp. If things go incredibly fast, you wouldn't even notice it. There are certain things I do believe that they were called Z atoms.
Mm-hmm.
Little high light particles that shot through. I think the astronauts saw this. I'm not 100% sure whether this is a wives' tale or not. There you are. I'm just going to take it with a pinch of salt.
Mm-hmm.
Z atoms, I believe, is what they were called. I'm not sure. And apparently they travelled through them, but didn't leave any hole or any holes in the. But they could observe these. Now that's a very interesting thing. What was that? So it was travelling at just the right speed, or is it at just the right heat?
Who knows? Conditions were right.
So I guess there is fusion, and then there is beyond what fusion can do.
Yeah.
And that's a basis of speed. So I think if it's too fast,
Yeah.
it won't fuse you.
Uh-huh.
So fusion has to be done at just the right speed.
Mm-hmm.
Maybe it needs to get quicker depending on what it is. So iron.
Yeah.
Is the star bashing things too fast when it reaches iron? And it explodes because it went too quick.
Maybe.
There was nothing to push back off because stars rely on that pushback, right? To cancel out the... But if it goes too quickly,
It cannot do
it
it.
knocks you off balance.
Yeah.
And that causes an instability and could cause it to pop. Is it not fast enough? That's another question entirely. I like this because it's reciprocal.
Yeah.
And then there is that fine line. And is this why laboratories can do it and stars can't? Most stars can't fuse past iron. They explode. But labs can. What's that about? Is it about the speed?
Yeah, conditions are different.
So if you do it too quickly, doesn't it break apart?
Yeah.
If you do it too slowly, it's not enough. Not enough to cause the... But if you get the ratio just right, is that why you can go beyond what stars can do and jump the island? So the brain can't register certain speeds. It has no way of registering that. And I believe that stars are the same. Go too quickly for a star, and I think it won't register it. Because you're going faster than what it can fuse.
Yeah.
Interesting. Interesting. So, yeah. Why was I thinking about this stuff? Because, we often believe that the speed of light is the fastest object, yes?
Yeah.
Or the fastest constant. But if it was the fastest constant, then black holes would not be able to gobble up stars. Because the light would escape.
Yeah.
Quasar. Interesting. Very interesting. Now, is that technically light, or is that a vortex that's lit up by the mass of stars in the galaxy? And black holes that are made from a neutrino tend to wander. They seem to they're like little spiders on webs, the webs being the magnetic fields. But something is pulling it towards the center black hole. Well, how does it know where it's going? It's unlikely, and very rarely does it ever swallow any planets on its way.
Yeah.
Or, stars. So I think stars are able to deal with that. And again, they got to know their positioning as well. So what's in control? And there again, certain black holes feast for a while and then they stop, regardless of whether the stars want that or not. They can orbit for a bit, but because you're seeing that now, you believe that they can always orbit. No, I think the black hole is chewing. It's feasting. It's pulling apart stuff. So it's gorging. It's got a full belly and it's digesting at the moment.
Yeah.
Then when it becomes hungry again, or therefore, we would then notice something else happens. It's feasting. And if it is, then it's pulling something in. Now what is that? And then what keeps the stars orbiting around this area? If it was the stars that had a choice in it, they wouldn't orbit it. So there's another speed at play. And then is light truly coming out of the star, or is it a byproduct of this pulling? So if we look at it, that we've got a lot of darkness in this universe, yes? A lot. So that means that the star, there's a lot of this stuff we can't see, yes? Now, if it's this side and a black hole is over here, can it pull these particles through the star? And is that what's pulling the light? Yes, likewise, some of it's pulling this way, depending on what it is. Makes me wonder. Honestly, it does. So yes, perhaps stars are traveling at this speed, speed of light, blah de blah. But what's that pull ratio? And have we ever seen it? Have we ever been around long enough to experience that? You know, because life is often like that, isn't it? Where we're born into this sort of bandwidth. We believe that everything we see is what is. Because we can study that and look at this and look at that. Or study ghosts. It's nigh on impossible, right? But then, okay, study the darkness. Well, that's kind of challenging because you have to be able to see the stuff that is there in order to make up the picture. But yet you've only got, like, what, less than a 20% picture? 80% of it is just not known, which would be the darkness. Or if you want, you can invert it and it can become light and then you dim down the stars. But still, either or. Interesting, very interesting. But yeah, no, going times 2 the speed of light. And yes, collecting radio transmissions via the signal, interesting. But there's another signal, right, called the light signal. What happens if you could capture that? Can you then look back in history? And as while the universe appears to be as vast as it is, it's a lot of data, isn't it? So, let's say you build a really good telescope and then you start viewing some really distant off stars. You can see it. And in your ratio, it's alive. But in reality, and which version of reality is actually true, that thing is already dead. And if you're seeing planets transit, and let's say then you can dim down the star and then you can make the planet look even more visible in that way, bouncing off of its light. That planet, I assume, don't want to make an ass out of anyone, is also dead. And you're seeing into the past. That's very interesting. Now, that's not it. Let's say if you made technology even more forwards, right? So technology often progresses. That's the way it is. And first off, it's a struggle to see distant stars or planets. Then you're able to see distant stars. You can figure that they've got a wobble effect or a transiting where the star dips for a bit, tells you that there is a planet orbiting that star. It's not always that way because it has to be around the equator and it has to be a certain size. Okay, so it starts off like that. Then a little bit more, little bit more, little bit more. Then you're able to dim down the star and basically heighten the exposure on the planet. The planet then becomes visible. Wow, fucking hell, breakthrough. It doesn't stop there. Now if we keep going, what happens if you're able to then zoom in to that planet? Now that seems really far-fetched, doesn't it?
Yeah.
Could you imagine that? Making a load of darkness, collecting this dark stuff, this antimatter, and being able to look through it like a magnifying glass and stick it inside a telescope. What more could you see? If that is possible. Now, you never know. And again, science has got to ask these questions because if no one's asking these questions, then no one's experimenting. And you could be missing a fucking gold mine. Quite literally. Now, anyway, let's move away from that for a second. But let's say now we look at the planet, we see it Jupiter size, and then we're able to zoom in. Now we're able to see the cloud deck down to a postage stamp. That thing's dead. There's no longer there. We just ain't got the news yet. And now you're seeing it back in past. Now, what happens if you're able to see through the cloud deck and then start to see landmass? And oh my god, it wasn't a Jupiter after all. It was an Earth-like fucking planet like Earth. I'm seeing people walk around on that. Oh my fucking days. Did they leave? I don't know yet. We haven't got that much of the story. But we definitely know that star's dead. That would be a reality feed. Could you imagine sticking that on TV? Real life East fucking Enders. Alright, if they go into their houses, you might not be able to see through the houses. How could you imagine rigging some way of making thermal imaging to see that far? So that you could see their heat print walking through. You know what they looked like when they were walking across the land. Also making out colour as well. Oh my days, look at their heads, man. Jeez. They've got no eyes. They've got no eyes. Have you seen a wife? They've got no eyes. And you're still having a good old look at that. And then you can tell your little AI, oi, remove their house swarming. And it does. And then you can start to see them operating inside their houses. And it sounds like such science fiction. It sounds like science bullshit, doesn't it? But it's true. You can do this. Maybe not with the technology you got right now. What about 100 years from now? 1,000 years from now? With progression. With the audacity to be disobedient little humans. And decide to do that. Do you ever think that something is needle and threading you to go this way? Internally, externally, learnally, and have a look at that stuff. Now that is interesting. Now what happens if you record all of that from when you pay attention? And likewise, you haven't got the message on new stars that have been born. That's interesting, isn't it? They're so far away that their light hasn't even reached you yet. Reverse that process with the... it works with a piece of string. You know, that's still travelling towards you from this point. You can't see it right now. Speed of light is so slow, man. It is incredibly slow. Still haven't received that message yet. Still haven't. A douche. But by the time that you're getting that message, oh, it's all over for that star. That's all gone. But yet anything you see on that, and the evolving that you see on that, whoa. I mean, that's incredible, right? And then the more magnification that you're able to get, do you know another weird thing happens?
What?
Well, you start seeing more stars beyond that ratio. It's a bit like the boat. You know when we're saying about the boat dips off the horizon? And then you can take, and you're like, nope, can't see it, it's gone. My eyes are limited, maxed out to what they can see. And I do believe that sight bends. Because light bends. It's just the way it is. Let's say massless. I don't know. And then you take a camcorder and then zoom in. Oh, I can see the boat again now. No, you can't. Yeah, I'm looking in. Oh, yeah. Yeah. It's quite good, isn't it? Oh, it's gone now. Oh, shit. Now I'll take my telescope. Yeah, I can see it again. So when you're able to see magnification from that far away, don't be surprised when you're able to then see, wait, I can even see their star constellation. Wait, there are stars there that I didn't even know existed. Yeah, you know all of those laboratories with all those maps of the constellation? Yeah. I hate to tell you this, but you just mapped out a stamp. I quit. It took me centuries to do this. And you mean to tell me that's not enough? Yeah, actually, in fact, you don't have enough resources on the planet to map the stars. You only have enough resources to map the stars that you see in your vicinity. Anything beyond that, forget it. Give me my P45. What's that? Give me my P45! No, I'm just kidding. You know, you probably wouldn't be staying for that because that's all round in every single direction that you can imagine. If you're seeing it over there in a Stampitch note and you're seeing even more stuff come through, shift it, and that's over there. And then now go down, 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 down. You know how you satellites use it to map the Earth? And it's little tiny stamp at a time, and then it has to go in all directions in order to cover it all. Imagine doing that with a universe. Now, on its bounds. And then would you know where it runs out? For as long as that light exists, well, your story's being spoken. And it's going to lead me on to another one, right? I love science, I do. But I also love this, I don't know, you might call it God. I call it divine, collected.
Mm-hmm.
All of those vessels that are all around, or, you know, I guess it's probably not to a human perspective just yet, but you'll open your minds, I'm sure. Imagine all those life forms everywhere. Seems like such a small pocket, doesn't it? And the stars in your vicinity seem like there are so many and you haven't seen anything. Don't get so disheartened. Go stand on those stars, well, planet around those stars, and look out again. Wait a minute, there's even more. I think it works in circular circumference. I think it's a bit like the eyes. But when you see this much, if you're standing here, you see this much all the way around. But if you then were to stand here, you see the same again. Sort of like circles within circles. And then the star constellations get a little bit more. You don't have enough metal to map it all, I think. I think there wouldn't be enough, or enough to drill the holes out and put the LEDs in. Thank God for computers. That's all I say. And even then, I think that you haven't got enough to build memory to be able to, or hard drive space. Thank goodness for CERN then, in that case. Wait, was it the internet was made to hold large amounts of data without needing a disk? Not really sure how that all works, but there you are. I was going to say something. I definitely was. But I think I want to leave it for the one that's behind there. Yeah, I'm going to leave it for that one. I think I'll save that for another one, because if not, it will get too unpacked, to be fair. But yeah, imagine seeing life forms from that moment, watching how they respond from, well, very long distances. And what's more, how inconspicuous could you make this? You know, you're looking for fleets of ships that are around. That's not necessary, really. If you know that there is life, then you just need to sit something here, and what, it can view whatever you want over there.
Yeah.
Now the question is, can you view that very small thing there? Yeah, you got to think how small Hubble is compared to the Earth.
Yeah.
It's tiny, right?
Yeah.
It's minute. Think how small a telescope is. Look at what you can see with it. So, very small object allowing you to see, you know, if you have loads of resources, lots, because that's what it's about at the end of the day. Could you imagine knocking the core out of Jupiter? The metallic core, if it is a metallic core.
Mm-hmm.
And you've built everything. What should we build? What about a planet-sized telescope with lens using the sands of multiple fucking planets? Could you imagine that? You'd be like, well, I can't see anything through it. Yeah, hold it up over there with this one at this. Oh my God. Yeah, you can see something over 1 billion light years away. Actually, maybe 2 trillion times 1 trillion. It's like I'm looking through their window. I don't want to watch them get unchanged. What could you see with that? That would be not so inconspicuous, would it? But it would allow you to see more from your perspective while remaining hidden. You'll know that unless something built something to this size, this stature, what about the size of a star?
Yeah.
And a good old look around, right?
Mm-hmm.
Well, if you made something that big, well, then you would know you'll be able to see this much. The small instruments would only allow you to see this much while standing here, the same way as taking a camcorder and zooming in. Yeah, I can see the boat. With your eyes, it went off the horizon, yeah?
Mm-hmm.
Now with a camcorder, I now can see it. Okay, now can't see it. I'm maxed out on my zoom, and then I take a telescope. All right, I can see it. Okay, it's gone again. Okay. Here's Hubble. I can see it. So the more data you get, the more bigger the object becomes.
Yeah.
But if you think about this in a strategy, Well, if that ship only had a sextant on it, or I don't know, can't remember what they're called now. Is it a sextant? Might not be called that. It's not called that. Anyway, an eyeglass, yeah?
Yeah.
Arr! There's no land, hoy. But you're looking back at them with Hubble thinking, I can see a ship.
Yeah.
But they can't see you.
Yeah.
But you can see them. And if I zoom in a bit more, oh, I can see the captain. Lovely. All right, go get him. That then becomes a hierarchy in itself, doesn't it?
Yeah.
Because from your perspective without needing to move, guess what you can see? More of.
Mm-hmm. Yeah.
Then does this change your paradigm once again? You know logically that if there was life here, life here, life here, and maybe life over here,
Yeah.
the chances of you all seeing it are next to 0.
Mm-hmm.
Shouldn't do that. Don't you look at that. If not, it'll stop moving. Oh, it will move. Anyway, if you can only see, let's take a red pen maybe, or a black one. No, the red. If you can only see this much, guess what you're not seeing?
The rest.
You can't see the life, can you?
No.
So you would believe that life is not about, most certainly not intelligent life. But then how intelligent is the life you're assuming? And then how aware is it?
Mm-hmm.
How much has it left its planet?
Yeah.
How early on did it leave its planet? You know, by and large, whether I agree or disagree, everyone says I'm wasting my time, yes?
Yeah.
You know, you waste your time, you waste your time. How much time have you wasted on war?
Yeah. Exactly.
On battle, on destruction, on empire takedowns and shit? Because time is energy, and where your attention is, so they tell me, is where your energy goes. And I'm like, yeah, but if I do what you want me to do in that regard,
Mm-hmm.
then you would have to lead by example with that.
Yeah.
And so far, that time versus energy, and then energy versus what? The monopoly system? Let's play Monopoly. Well, how long for? Another century? Then we would think that life forms, or we, are more intelligent. Where does intelligence sit? Well, it's a freaking spectrum. A bit like the periodic table, right? Where does intelligence sit on that? And then where do we think we are versus any other life form? So it's easier to just disbelieve that there are any other life forms, right? So we'd be like, no, there isn't any. Well, that's comfortable, isn't it?
Yeah.
Doesn't mean it's real. Man, I've been manifesting that for as long as ever. Manifest it all you want, doesn't mean that it's true. And then how far does your quantum mechanics go then? Only as far as you can see. See, so when you go to space, it changes your paradigm.
Yeah.
Yeah, that's one reason. One reason to do it is probably because of this. Because depending on whether this life forms out there are hostile or not, fucking hell, look at your own planet. Some life forms have been hostile and some haven't. Some have been domineering and some haven't. We look at this with Boudica. We can only take our own life and assume, but assumptions be the mother of all. I disagree. We don't know enough data to comfortably, certainly say that there isn't anything else. So I'm going to assume that if this planet is abundant with life and that there are multiple star systems out there added into multiple galaxies, yet we can't see that far away, the planet is education. And that education, real education, it tells you your limit. But it also shows you, with your initiative, that you can see beyond. So with my eyes, I believe that that ship is gone. And then I take a tool. Wait a minute, it's there? I can see nothing, but yet I can see a captain and there seems to be a mutiny going on. Okay? Now I take that bit of information and I look at it and think, that's happening here. Is that happening there? And is this the lesson for that? which is called the awakening, and it never stops. It's the awakening on Earth is limited to your paradigm until you can shift your paradigm.
Mm-hmm.
But it's somewhere along the lines, you have to be away from this. If you think that this awakening here is anything to go by,
Yeah.
well, what do you think? You've reached the full of knowledge of awakening? Nope, you keep hitting the glass ceiling, don't you? And you go no further, and then you believe that's it. It isn't. That is a mighty step. Then the more you understand, well, the more you grow with that. Symbology. Yes, the universe is full of symbols. Some you see on your own planet, and some that are held with other life forms. That's interesting. Could you imagine what they do to you?
Yeah.
Then if you see more life forms, because you built something, a tool, to be able to see more by applying this knowledge here, why did you build telescopes?
Okay.
Galileo, right? I don't want to be looking at ships. And why did they have those lookouts for? Because the more information, meaning the more further distance you could see, the more you would know if an armada was coming for you.
Mm-hmm.
And what did that mean? That gave you time. Back then, the strategy was who had the most powerful lookouts.
Yeah.
Therefore, those messages could be relayed, and you could have troops ready and waiting, which would then take them by surprise when they're trying to take you by surprise. Fucking horrible, really. Most had it before this time. It was a tool that the Mayans would have used very well. I'm almost sure of it. The ancients loved the stars. They loved it. They were star beings. Good reason for that. Anyway, we'll get onto that. So, any other life forms that do this, and remember, what have they got to do? They've got to leave their planet. Why? Because there's not enough resources on their own. They will work this out very quickly. And then, who spent a lifetime hiding this stuff? Like Galileo, how much time was wasted on that? So, if we went back to the time of Galileo or before Galileo, I'm sure he is just the first one we know about. But I'm almost sure the Mayans had built this and left replicas laying around. And this got hidden, and it had been hidden, but Galileo was the last person because it was hard to hide him. It was too late to hide him. But if they could have hid him, you may still not know this today, and you may still not have telescopes today.
Mm-hmm.
And I might not be having this conversation, I actually would, but still, because you look around at what they were doing back then, so you know this technology was about.
Yeah.
And one thing we guarantee, people hide stuff all the time. They suppress things. This has never stopped.
Mm-hmm.
Now, where life forms here do this, and this seems to be number one priority,
Mm-hmm.
how many other life forms out there made that abolished? Didn't do that.
Mm-hmm.
Rather than suppress house arrest and all the rest of it, they lifted these people up.
Mm-hmm.
Hey, do whatever you want to do, because at the end of the day, well, it's your kingdom, ain't it? But there you are. That's cutting off the nose to spite your face. But there you are.
Yeah.
Yeah, it's up to you. What if you lifted those people up? What would they have done?
Mm-hmm.
How far back would that knowledge have gone? And therefore, how much more better would your equipment be as a result of that? Let's say if we truly did liberate people, truly liberation, to lift people up, and then those ones that are lifted up, what do? Well, they don't sit at the top, do they? No, they start offering hands down to other people and pulling them up above them with this knowledge that they learn. Because they know that that's how you build to the stars. It's not one person stays up. They only get their moment, but they often put their hands down and pull people up. Come on, look at this. Look. And then when they pass that data on to someone else, there's someone else who's different to what they are, more scientific based. They take it even further than what Galileo could have done. Imagine that, right? So Galileo doing what he did, lifted up America many years later? Think about that. Okay, there's a hell of a gap there. Look at that gap. It's huge, right?
Yeah.
That's a huge gap from point A to point B, yes?
Mm-hmm.
But that's because the world is just so slow at that. Could you imagine if Galileo had lifted up NASA people back then? How big would NASA's telescopes be? The NASA that we know today, how much more, better, bigger would their telescopes be if they had already, right? You see, after that much time, that's a leap. These are the leaps. They're slow, but America takes massive fucking jumps, right? That's the one thing you've got with America, they jump. When they get something, they jump. It's huge. And it kind of makes up for lost time, but it's really, really slow progress. It's fast. Without that, we wouldn't be halfway anywhere where we're at now. And Russia too, gonna have to give credit, where it's due. Russia were taking leaps with this stuff as well. America was taking leaps with the telescopes, understanding of space. They are massive leaps. And that's true with Neil Armstrong's statement when he walks onto the moon. That's very true. Now imagine other life forms that had this. And now it plays out on the planet, doesn't it? Certain nations are taking leaps. Other nations are stuck in the past. Shit me, this nation needs a time machine to come and visit us. I'm not even kidding. They need a fucking time machine. We're like fucking living replicas of fucking dinosaur. They might as well bring a fucking brush and a trowel. Start dusting us down. Oh yeah, fucking, oh, you specimens. Where the hell are you from? The fucking future, apparently. Do you get what I mean? It's funny, I like to have a play around with this. It's just great wordplay as well. And then there are other nations that are even more prehistoric than what we are. Fucking hell, man. You're still back in fucking, in that? Jesus. And then other life forms on other planets. What if it was different? What if it was different? And then where do you want to be as a nation or a world in that? You know, and if NASA had resources and it not be based upon money where it bankrupts America or anything else like that, and let's say Russia and China and EU, if they had unlimited resources, how big do you reckon their telescope would be? They'd already have fucking transformed Jupiter by now. If money were no object, which technically, should it be? That's the question. Should money be the object? Or should knowledge be the object? And money is the tool that props you in the meantime. Do you even need it? Society, food, trade, that stuff should prop you. Or shit me, make robotics and make them into robots, right? Wait. Robots is a Czech word for servant, is it?
Yeah.
Sir.
Serve, yeah.
How big would the telescope be now? How big would the lenses be? Well, that's far too expensive. Why is it expensive? Well, because we can't take it from the ground. Do you have any idea how much money that would be? And robots? Yeah, we do it for free. Just fill us up with some fuel, will you? Here's a little nuclear engine for you, and one for you, and one for you. Oh, look at that. You don't need food. You don't need water. I suggest you get over there and start doing your work. Would love to. Are we going to have posh robots? Oh, yes, I'm now going over there. It's so lovely. How are you going to have posh robots? You talk like in it, bruv. Could you imagine that? Oh, if you could tailor their voices. I mean, we're sweating it now. But anyway, yeah. And then, how much more could you see? Then does that change your paradigm again? Because life then starts to appear a bit more abundant. That's plus your own.
Yeah.
Because you can see more. Then you find out you've got clusters of life.
Yeah.
And then you look again, and then there's even more, and even more. And then what do you do with that information?
Yeah.
Well, it changes you, doesn't it?
Yeah.
It makes you think, oh,
Yeah.
are some of them more advanced? How are they operating?
Yeah.
What are they doing? And then, is there going to be any nation on this planet that's going to go, That's fucking inspiring, that is. Yeah, we need to be like that. Wise beings would look at that and be like, you know what, that works, but the rest of that shit doesn't. Okay, got to take God's role in this one. Now, this over here works. Right, gotcha. Scram that together. Oh, look at that. I just made 2 bits of information, being a piece of hydrogen from this one, a bit of hydrogen from this one, and there's a bit of helium. Now, what's good about this? This, smack it in. Oh, yeah. Do you notice that the more you see, the more it codes your reality, which affects your sociology, which then triggers psychology,
Yeah.
and then makes you even more determined to be better?
Mm-hmm.
Or we can just sit in this small belief system here, like, I don't know if I can shrink myself anymore. I think that's good enough. Best I'm going to be able to do for you. Yeah. It's not happening. And then, what type of intelligence is that? And if some of them are really advanced, you'd be like, hang on a minute. Well, that's like what we were doing. Wait a minute. Hold on a sec. Did you steal from me? Well, you weren't doing anything with it, were you? You were just using it to do this. We watched. We saw it. We see it. We did. Oh my God. We got God watching. We got the divine watching. And now we've got other life forms watching. Fucking hell, there's a lot of watching going on here. Hello, police. No, just, you know. The animals are like, don't care. Humans are like, build house, hide out the way. So just remember that when you're looking up at the space.
Yeah.
Give it a wave. You'll look crazy to everyone here. The more prehistoric nation you've got, the more weirder it looks, by the way. But the more advanced nation you've got, the more that's like, yeah, that fucking makes sense. I'm doing it, mate. I'm doing it. Fucking love it. Because you might actually be waving at something, you know? Do you think they know? They fucking know. Oh, shit. How do they know? Oh, fuck. Yeah, getting you some paranoia right now. I see you. That'd give them something to fucking write in a book somewhere, wouldn't it? Yeah, and that's the bit. So if we take all of the knowledge that you know, and if it was passed back, compressed, and the truest way should be, again, I think it's a bit selfless, but that's usually the way it works, isn't it? But we don't see it. But when you grab someone and lift them up,
Yeah.
well, usually with the information that they've got, like Galileo would be picking people up. He'd have his moment. Yes, he'd have his moment. Rightly so. Because it fires this, keeps it going. Well, he didn't. He got his moment where it was locked away. Very sad. And then that makes you question, how long has that been going on for? Yeah. Galileo was the last in the... Too many people must have known. Too much was discovered. Too much was exposed. And then that shame happened and they all stepped away.
Yeah.
Probably a bit more so like this. Too many people know about something, and what does it do? You watch them, they step away because they don't want to be associated with that. That looks really bad, doesn't it? Lest we forget, indeed. Because, you know, if we were a little bit more minded, we got to understand the Galileo process, then he's able to, come and have a look at this. To a butcher, come and have a look at this. To a sailor, come and have a look at this. And again, does this get people thinking? The butcher's family now evolve into creating something even bigger. Who knows? And then that person then gets lifted up because what Galileo did. Which then starts to pick everybody else up. Come and have a look at this. What? This. Oh my days, that is amazing. And then Galileo has a quick look through there as well and thinks, it's pretty cool. I've had years to think about this. What else can I think about? And then he is the one that changes our understanding, which then allows a load of scientists to backpiece information off of the moons. So you can understand the moons of Jupiter. It's Galileo, right? and what he did back then picks you up now. So when we're talking about the comets that could smack into and how it puffs up atmosphere, this would never have be a conversation if it wasn't for what he did.
Mm-hmm.
And then you understand that that's a massive gap from then till now to start picking people up, you know?
Yeah.
And then with you having this conversation, right nor wrong, it gets people thinking. Until finally people start merging this stuff together until it enhances enough to be, okay, all right, we found it. We found North. You know?
Yeah.
We had to swing around a little bit. Okay, all right. We've got it. So what appears as being empty then starts to look a little bit more fuller. Now there's 5, then 10, then 20, then 100 life forms of different variations. And then who? Because then it becomes the pride then, doesn't it?
Yeah.
Who's more advanced? Ain't shit all you can do about it, but... And then how many others have the capacity to get to others? How many others have merged together? How many others have built beautiful things from it?
Yeah.
Where does artwork sit? Where does music sit? Where does knowledge sit? Where does understanding sit? Sure, some of them may be really friendly. Others may not. You've got it on your own planet. Some are friendly, some aren't. Again, and what is it? Earth seems to be the training ground, the proving ground, the educational ground.
Yeah.
And then, yeah, it's very interesting, very, very interesting. I do find this fascinating. So yeah, for me personally, I think the moon hides some secrets on it. Bulldoze that stuff out of the way. I think it was a icy, wet planet, let's say, and it had atmosphere, perhaps not the same as Earth, but very similar.
Mm-hmm.
And captured orbit. What happens if Jupiter starts nuclear fusion when the star explodes here? Then Europa is likely to be another Earth, right?
Uh-huh.
Then what happens to the outer planets? Will Jupiter then capture them and then we'll be like, oh, we just can't make this shit go away. How the hell did that planet get that big? And it will be even bigger. Why? Because it will still get some shards. It will then take Jupiter's spot. Jupiter then takes the star spot. As being this colossal, great big ball of burning. Then the fusion process starts and then, you know, the other giants around. Saturn, Uranus, Neptune get even bigger. Pluto gets fucking huge. Gets a load of those debris. Then your models will fail again. And then you'll be like, I happen to believe this guy is correct. He's got it right up to a certain point. But I think if you were to factor that into your models, that I think that we have seen another star here. And some of the moons are remnants, planets, that rearranged their orbits. Jupiter grabbed a few. The rest of the planets grabbed a few. What makes the rings on Saturn? That was an interesting one that came to me the other day. Some comets, meteorites, comets, will go the opposite way and smack into the front side of the moon. If spectacular enough, it will cause the debris to spread out this way. Yeah. More often than not, they hit from the back and shoot the debris into the planet. Therefore, no rings. Yeah. Rings come when it comes in this way. Avoids the planet and the sort of messed up frisbee effect and hits it this way. Then causes the ring system. And I think that happens less, and the back end of the moons or the orbiting bodies are the ones that get smacked the most, because the planet is usually bigger and therefore there will be a lot more pull. And therefore a moon that's in the way and that's why we don't see much of it. But there is the odd time when it just hits the opposite way. You know, it skimmed through Jupiter, let's say, but then bust out the other side and then smacked into the moon with enough force that it could have broken some of them apart. Because some of the planets that I see, none of them are rock mass. They seem gassy and ice, but not rock mass. And therefore, I would then have to assume that they might be all the similar size, but the gases are what separate them. And that would be why they're such lacking in liquid. Yeah, that's where I'd go with that. Lack of liquid. Yeah. Capturing of moons, and there again, if the star explodes, some of them close up, Mercury, goner. But again, if it's exploding or puffing off its atmosphere, or the star gets hit from the opposite side, and that's going to blow some debris. That's why it has a liquid outer, because it's trying to dampen the impact splash ratio. It can lose those smaller parts, but as long as it holds its center mass, that's the important bit. And if the meteorite hits into that, it's lost its mass, but it's also slowed it down. So it's lost 20%, but it's gained 80%. And even in the impact, the object that's hit in has lost 20%. So it's gained what, 140, 160? 80 and 80?
80 and 80, 160.
160. But it's lost 40%. From the object that hit it, 20% fell off, left 80. And the star itself lost 20%, but held on to its overall mass. Then that 40%, which is 20 and 20, whatever you want to, way you want to look at it, then hits into the planets. The planets will gobble this up because they orbit, so they're going to get into that. Depending on how fast it spills out, it's not going to travel at the speed of light. So if an object hits the star, it's not traveling at the speed of light. It's going fast, but now it's slowed down. Wobbled the star a bit, and this will probably cause it to pepper, but in a very... And then the planets that are orbiting sort of spin and take up all of that, and they eat it, which then they gain a bit more mass. So some get a lot, some get a little. Then when you take it for moons, the moon has lost, what, 20%? And then the object that's hit it has broke off 20%. That's 40%. So 40% enters into Jupiter. And the moon essentially gains a little bit more mass too. Now reverse it and it'd be 80 and 80. And then you keep your 20, which then what is making up the moon. So I think it's a 20-80 ratio. And it's not set who gets what. So, but both objects lose something. So the comet loses itself, but the object it hits loses some of itself. But overall, they hold on to a larger amount of mass. Very interesting. So I think the moon was wet once, and Earth has taken bit by bit with collapsing atmosphere. If we have an ice age here, and a meteorite hits us, you got to understand, large chunks of that ice is going to... Now, if it goes towards the star, it's going to end up getting a comet tail, and it's going to cause it to act like a propulsion. If it hits the other way, it's going into Mars. Some of it's going into Jupiter. Some of it's hitting on Europa, blah-de-blah, X, Y, Z. So it's seeding, sprinkling. So I think the moon... Could you imagine this, that the moon was the last civilization were living on the moon? Big puffy atmosphere similar to Earth's. And the star did something, and it was caught in Earth's orbit. Could you ever imagine them jumping over to the Earth, figuring that out? It sounds a bit weird and wonderful, but... Or they were a dying species on there, and as a meteorite hit the back end of the moon, it knocked life forms. And could this be why we have such large ice at the North and South Pole? And then is it really, really salty? And if it is, did it come from the moon? Now, when things hit the moon, it creates a dust cloud, which then creates an ice age. Evidently, that's a very weird thing, isn't it?
Yeah.
Which then puts us in losing atmospheric gases as they collapse down. So it works more on Pluto, puffy, collapsing, puffy, collapsing. When it's collapsed, if it gets hit by a lot of meteorites in that, then it's going to lose a lot of its atmosphere for the next time, and eventually there's no more atmosphere left to puff up. And then what holds on to a small mass of atmosphere? I think it's the sand, the impacts, which then cause the stuff to go into crystal, and the crystal is just aggravating the light in a way that causes it to heat up, which heats up that thin layer of crust, which then, if you dig into Mars, it's going to get colder the further you go down, so you're going to find ice. But the crust isn't. Some of it's coming from the star, yes, but also I think it's aggravating the sand, which causes that very thin layer to be quite warm. And then on Earth, we're a bit more closer, and deserts are hotter. Is it because of the sand? Because of those little tiny bits that, gather them together, and then the true devastation is apparent, isn't it? If we say glass, well, crystal, it does the same. I just don't think we can see it. That's the thing. And we can't experience it. It's not that much. But perhaps to ice, it is. Again, it's salty there as well, so could that be a factor too? But there again, salt does freeze. But what is it going to take for the planet to freeze? What sort of event would it take for the Earth to freeze over? Well, a meteorite hitting the arse end of the moon and causing dust which covers the planet. And bit by bit, it will uniform to the equator, won't it?
Yeah.
Some particles get trapped in the magnetic belt and get thrown in at, where would we say? The poles?
Yeah.
Some of it go around and then bit by bit rains in, or because we've got the moon, it hoovers it back up again. Ready and waiting for another impact. So before, there was probably a lot of something hit the moon, shards 40% or so bounce over to the Earth. And therefore, over 4.5 billion years, this would be doing this, which wouldn't cause a ice age. Maybe it would change the temperature quite a bit, but it would be changing the composition slowly but surely over time. And mountains. Mountains. Are mountains truly mountains because of the crust is pushed up? Or some of them, are they meteorites? Big hunks of fucking rock.
Who knows?
I dare say tectonic plates is responsible for the dips and the valleys and... No, I'm on about the ones that are oddballs, like really odd. If we could take an MRI scan of that mountain, are we just seeing a tip of an iceberg? The only really way you would know is if you tunneled into it. If you could tunnel into the mountain.
Yeah.
I was once doing that thing where we were putting those piles in the mountain.
Yeah.
Yes?
Yeah.
In order to make a platform and build some houses, which then would go on to make a space program. If you've got fuel, you've got need. Money moves people, fuel, and whatever else. And then you've got capability to get things up, and then it gets more easier. And then you build rockets onto it, and it's already up in the atmosphere, blah, blah, blah. Plus the pressure is less. People climatize over generation. Space programs become easier in that way. But the main purpose is that once you put in a pile, you bring up a lot of debris when you... I've told you about some of it, that when it starts to lift up quite high, you've got massive lumps of ground from beneath, really deep down. And that's interesting. The more you have to take it off and knock the pins out, and then you knock off the drill. It looks like a giant drill piece, but they're broke down in segments, yes? And when it drills down, the more it comes from the bottom, that is soil that hasn't been touched for a very long time. And it's fascinating to look at. If you do this on a mountain, it shows you deep down what it's made of. Now, if it's made of rare earth minerals, then did it come from Earth? And are we looking at a mountain that the plates just pushed up? Or are we looking at a massive hunk? And they'll say, well, it would have vaporized, it would do this, it would do that. No, if it hit the moon, it already take a knock. Then it depends on how fast it was moving in the first place. Not all objects are moving super quick. Some are, some are not. Some are really slow. If it's already hit into something, can it then, imprint Moon, take bits of that, and then crash into the Earth. Just sort of plant there. Essentially, crash land on any of the mountains at all. Any of them. Some of them have got to be oddballs, haven't they? Yeah, Olympus Mons. Yeah, interesting. A lot of it seems to be quite flat. Earth seems to be quite shardy. Especially if you find hunks of iron in there. Then if you do, then we might have already had a star. In its explosion, it hit into a Jupiter-sized, and then the order changes. Do you think if Jupiter gained fusion, what would happen is it would move forwards towards the star, and they would try and steal the center?
Or it would steal the planets.
It would take the planets in its way forwards. Yeah, this is what I'm on about. And likewise, if the star explodes, it's gonna crystallize those objects that come out of it. Everyone thinks big, massive, hot explosion. No, it cools down incredibly quickly. That creates crystal. It's interesting. It's beautiful, actually. It's really fucking beautiful because if you could see it, it's fucking beautiful. It's really gorgeous. What you're seeing when you look at the Oort cloud is you're looking at remnants, right? It looks very boring and yuck, but there's not much light there. That's the thing. If NASA were to send the Voyager probe with a load of freaking lights on it, really bright lights, and even then it's inky black as it is, if it was to catch some of these chunks, they crystallize. They're really beautiful, depending on what type of mineral content the star has popped. And some of it is in fractures, yeah, and some of it is in big hunks that come out as really hot, and then they cool down super quickly, yeah? So super cooled liquid, which crystallizes because it cools down too quickly. So it becomes brittle. Yeah, in a star understanding, okay, not in a human understanding of brittle. Yeah. I mean, you couldn't go up to it and crumble it with your hands or anything, but again, and the more it smacks into other objects in each other, that's when it starts to knock and smooth it down. Yeah. That's why we see a lot of them look potato-y in shape. That's bombardment, that is. That's really, looks like a lava lamp. Yeah. And some of them do end up looking like that, but more so than not, crystallized. And these chunks fly out. Well, if it hits into Jupiter, depending on what hits into Jupiter, it's going to have a splash ratio. Yeah, some of the atmosphere is going to be lost in that. Yeah, some of the crust is going to be lost in that. But what it gains is far more. And then, depending on what that is, it can make more gas. And then it can start off the fusion process, which when it does, which it will, I'm almost sure of it, it's then going to disrupt the orbit. Things are going to now no longer orbit what was not there anymore. So it was there, orbit in that. That was the heaviest object. It seemed to take dominance over that. Then all of a sudden gone. Well, it's going to cause a little bit of an arse ache for everything. But then Jupiter, let's say if it takes enough chunks, and this becomes the new center of mass, gravity area. This will move. Well, I don't think it will. I think the other objects will move around it. Then it will begin orbiting that whirlpool, if you want to call it that. And you never know that Saturn is likely to become two-star system, binary, because Saturn and Jupiter will gobble this stuff up. And Big Brother isn't half wrong. I think our Earth, our twin, is Jupiter, not Venus, not Mars. Jupiter. Look at the weather. Look at the weather systems that we've got. Look how crazy it is here. So yeah, our Big Brother is not far from it, to be honest. And then whether Earth becomes an ice giant in that process, or becomes more puffy and becomes the next Jupiter, well, remain to be seen, doesn't it? But there again, if, let's say, Europa started puffing up and started looking more habitable, and in that instability of things moving around, it sort of causes the volcanoes to get a little bit crazy. It's being stretched and squeezed in all directions. This is going to help the core to become molten, depending on what objects have landed on there. Iron, nickel, and so on, steel, whatever, I don't know. You're then going to get an electromagnetic field generated. Then if it keeps with orbiting others, it's going to also collect objects too. It's also going to gain mass. It's going to create land mass. That land mass is going to get hot in that area, being close to Jupiter, and it might start sweating the sea, which then will allow it to release water, and then rivers become apparent. If humans were to see this in this process of what was is now changing, and now Europa is becoming habitable, do you think humans would jump ship? Yeah, you would let go of everything that you did, and that would be number one, wouldn't it? That would be desperation to do it. You would try. That's when red tape is lifted. You'll be building glass biomes. You would try anything you could, just enough to get you there. And in the process, if something hits into you and it knocks off a few seeds in the process onto Europa and other bodies, you reckon it would seed? After all, the seeds would just need to wait until conditions become favourable.
Yeah.
So yeah, something similar to the moon with that. I think the moon, and if you're going to find artifacts, I think it's going to be on the moon. Yeah, definitely. I almost feel it. It's going to be broken, a lot of it, but I think if you dig it all up, I think that's when it's going to reveal itself. Because I think we got its atmosphere, and it's not because it's too small it couldn't hold on to it. Nah, I think it's when it collapses down and gets cold. And again, I think there's multiple ways to have an ice age, and it depends on the variation of whether you're going to have a big ice age. Ancients back in the time said that they noticed strange lights on the moon. You know that?
Yeah.
Strange fire marks they could see. Something must have hit it. And then a little bit after they were talking about that, the Thames froze over. They were skating in places that they've never been before. So something hit the back end of the moon. You didn't see it, but the dust came over and caused a mini ice age. That's what I think happened there.
Yeah.
So there's one way to create an ice age. Things hit the moon, create the dust. The dust then blocks out starlight, let's say, heat. And the heat radiates into those objects around, and then the moon's got to spin around. Probably wasn't a lot of dust, but you don't need a lot. 20% reduction would be enough to trigger a small ice age. 30, 40%, that's going to trigger an intense ice age. And I think ice ages are intense. So yes, I believe in cycles of hot and cold. Don't get me wrong, I really do. That's another factor entirely. But the wider scale, that's orbit, never completely perfect. So this is going to trigger hot and cold seasons. More so, it's going to be, yes, you're still going to feel summer, but it's going to be colder summer, but it's going to be a lot warmer than it would be in the winter, and the winters become more colder. So which one is it? Did the summers get cooler, or did the winters get colder? That's orbit ratio. Then another type of ice age is done by meteorites smacking into the moon, kicks up the dust, covers the planet. Humans could do this anyway. What happens if you took loads of shields up into space and knocked out 20% of the sun? You take it further and closer, more closer to the sun it is, then the more of a shadow it's going to cast over the Earth. That is going to knock out a level of heat, and it's going to shade you. That would cause an ice age. Another one is a meteorite hitting the star. Depending on what it was, it's going to hit the star, and this is going to cause it to splash. It's going to splash off its top layer. Doesn't matter, it's not going to break the star, because the stars, that's why it makes this. It's an impact protection. I think that's what it's doing it for. And then it's going to hold on to this new mass, and it's got to take time to start heating that back up again. You know, take a raging fire and chuck a load of coal on it. Do you notice how cold it gets, especially if you're sitting around outside it? Oh, days, I need a jacket. Can you imagine either? Oh yeah, it is a bit cold, isn't it? Get mine. All right then, here's your jacket. Mad person number 2 then. And then when you chuck the coal on it, it takes a long time. Maybe, I don't know, 15, 20 minutes, and then it rages up. And then it's more hotter than it was to begin with. So it's wise, in that way, when burning fire, was to chuck things on a little bit at a time. This caused the fire to intensify. But throwing a large amount on, and then depending on how much coal you just put on the fire, you douse it down. So a steam train would often do this. If you throw too much coal on it, it'd slow down. Because it cool it down. The fire, it needs to be raging. And then that's where it require air. But actually, if you got the ratio right, so it was raging fire, and you just chuck on a little bit. But it's more manual work to do that, though. But if you were to open the frickin' door, raging fire, and you just keep chucking it on, chucking it on, chucking it on, this will slow down because the heat is no longer there. You've cooled it, you've added a cold object into it, and rather than it radiating out into the environment or into the, I don't know what it's called now, forget it, don't worry, it doesn't matter. The heat is no longer radiating, because it hasn't got the energy to do so. What it's radiating in is into the coal, because it's closer. Once it's radiated into that, and then the fire then intensifies, then it starts radiating out. So that's another way of causing an ice age, and those ones are more severe. I think a little bit more longer lasting. So dust, easier to clear up. Interesting. And yeah, there you are. So the star being one, that would not be a good one. So that gets me thinking about a lot of things. That does, really does. So if you had a meteorite that hit into the star, it cooled it down, and the moon collapsed down. It's too cold. The Earth would still hold an atmosphere, but I think the moon would probably collapse down a lot more because it's got a lot more cooler air because it's being blocked by the shade of the planet. Yes, and then it reflects the light, and then it's blocked out. Then it's blocked out, and as it's blocked out, it's cooling down faster than the Earth, so therefore it'd be more inclined to collapse down the atmosphere, plus with the lacking of light from the star or heat, and then it makes it vulnerable. And meteorites never come one, they come in many. Usually it's many. Depending on what they've orbited around, they usually fracture. So usually depends on where they come from as well. So, and if the stars in the galaxy have disrupted anything on either side, that can send things. It might not send things straight away. It might move things towards its star system, but that star might throw it back out, and you can be in the firing line to that. It's unlikely, but it does happen. So it's possible, but it's not common. Then in the process, if that's hit into a few other things, then these objects will come. One hits the star, another one might be on line for the planet, but the moon gets there in the end and knocking over our atmosphere. Micrometeorites. But yeah, if you look at the moon, they're very potted. And if this was in the beginning, a lot of that atmosphere is going to be, Earth's going to have it. So, and again, if you've got a wet comet, I like to call them wet comets, the ones that have the comet trail. Yeah. If that skims our atmosphere, that's just sprinkled a load of whatever that has and is coming out of that comet trail, has now entered into the atmosphere, and it's now become a part of the atmosphere, although all of the comet didn't come or land, and it went and hit into the star. But if it bypasses Earth and just even so much as captures that atmosphere and its tail, and with Earth trying to break it apart, pull it apart, that has just seeded Earth. And it has caused the atmosphere to inflate a little bit more. So whether they land or not, what they're made of will either increase the mass, which seems less likely. It seems to be more about the atmosphere. It seems to puff the atmosphere. Which again, once you get to a certain size, you start getting more light. More light, more heat, more stuff to bounce around, jostle about with each other, and yeah, you get very hot. So yeah, I'm trying purposely to ignore this video here for a second, but because I'll go into that, I want to keep it separate. But it does link into it, so whether I do that today or not is another thing. But this is fucking cool. I got a little camera that moves. Yeah, AI camera. It's actually brilliant. I actually like it a lot. It's pretty cool. So yeah, we'll see how that goes. So yeah, I'm going to wind down from this one. So yeah, life is about perspective on that. And I often think that there is an invisible that we can't see, but it's made visible by the stuff we can see. And I think somewhere along the lines, these combine to create something. And the star creates this combination, and the black holes remove this from this, which pick it apart. But the star will explode once it's done and lets go of these things, whereas black holes will hold on to it, it doesn't let it go. It's mine. And they like to merge together, the reverse of identical twins? That's another question I was asking myself last night. Do you think that you could split a black hole in half?
I never thought about it. I don't know.
Yeah, and if you were to split a star in half, would it become twins?
Possible?
Would it, each one? I'm just, fascinated with this twin subject and reciprocal and different things like that, and yin and yang, and yeah, interesting, very interesting. But still, black holes like to come together in the end and die as one. Stars like to die on their own. So, very interesting. They sort of don't really. It doesn't mean that it's impossible that no stars have ever merged. I think some have, but I think it's less likely that they're a bit more. Ooh, get away from me! Wait, it's mine. No, that's mine. No, that's mine. They argue like twins, and then you've got another type of twins that are reverse of twins that like to merge together. Whereas here we're kind of splitting apart and merging out. I think this is all in reverse. Kind of weird. Yeah, and then it got me thinking about bacteria as well. That like the one that we can see and one that we can't. And depending on how these bind, which then causes the mutation, and then where's the glue in between that? Is a little bit of neither or neither in order to come together. And then it stops us from bleeding out, which is, again, something I was thinking about. How does all of this stuff not fall through everything else? How can I touch things? Because, I should technically be able to pass through it, right? Should be able to walk through walls, and something prevents it. Damn, man, we got empty space there, but it's still like, nope, nope, nope. Man. And what happens if I wrap myself up in all that nothingness? It will still say no, because I'd have to wrap myself up in the nothingness that shares, that bonded it together and created that. And it causes it to have memory. It remembers what it is, so it stays structural. So if I made myself of the same nose of what that is, all the invisible stuff, and I wrap myself up on it, yes, I could walk through that. But if I could walk through a brick wall, no, because it's something completely different. And then I have to teach this to remember something else, and then find out what's in there that binds it together. And then that might tell us whether that stuff is different to, and we're bonding it based on the two nothings that need to come together to hold the form, memorize the form, and stay in the form. And some things, just like trying to make sand come together, you can do it, but as soon as water hits it, it pulls it apart. Yeah, kind of a bit like that. Interesting. So it remembers. So that's interesting. And then ice. How does it know to be ice? Well, what's it bonding with? Something in the atmosphere, and it gets cold, and this changes this. Okay. Touche. How do you know to be water? How do you know to be steam? It remembers. Memory. Encoded memory. But yeah, so, and then it got me thinking about life is like this. And information is like this. So all the things that we think about now, it's 0.0001% of what is known. And how are we ever going to know it sitting here on a planet? And then what can we do if we leave the planet? Can we build bigger instruments? Why, yes, we can. Then is it about money? No, it's about getting it. And it's about lifting each other up in that way. And then as soon as you've lifted loads of other people up, then, oh, wait a minute, now they're lifting me. And then it becomes this sort of lifting each other up to become better as what we are and more knowledgeable. And that's kind of sharing the torch in real time as opposed to it being done over history. Like, it sort of picks up for a bit and then it drops down. And then people start picking each other up, but no more. And then it sort of fizzles down. And then we start picking up. Imagine if it was like that every single day. And then how fast could we make that? Well, we know how fast we can build businesses, move money, and do all the rest of it. How fast is this bit of it? Then how much more further forward does it put us? All of us. And then are we sitting ducks, or It's where you'll put your attention, my friend. It's where you put your attention. I've been waiting for you to say that. Because I just want to play back what you've been doing. Peas in a pod now, aren't we? Do you understand where your attention is and this, that, and the other? Where your energy goes and your time goes and your thoughts go is where you go, and that's where... And the world, we're all doing it. And where we've been focusing on this, well, whether it's right or wrong, is there another way? Is there a better way? What if we focused on that and not this? Now I ask the question, is any other life forms focused on that and let go of this? Did any other life forms ever go through this? Well, there is no life forms. Well, we've already explained that. Zoom in, zoom out. And then where does that put you as a protection? And then are they hostile, and then were they not hostile but saw us being hostile and then think that we're going to be hostile towards them? And how far advanced were they? Are they? And how much more developed to counter-attack that? Then are they going to ask questions if they're watching from a distance of how we are being and assume that if we treat each other like this, we're going to treat them like it? And then where does that draw a line as to what the response becomes? And then to not make it scary, to go past the fear filter, ask yourself the question if you saw this in others. And again, you would need a variety to be able to see it, where some are really advanced in this way, some are acting like this. It punches something into your reality and makes you respond or think what if and strategy. And then does it make it a waste of time? And then what are perceived to be good drops down. That's just where I look at that. You know, if it makes sense. It does to me. It definitely does to me. So, yeah, and I guess that's when they say to me as well, something else, that you manifest what you are. You manifest more of what you are. Yes, in the quantum world, that what you think about, that's your reality. But then, are we manifesting then by behaving this way as a world rather than individually? It's easy to look individuals, isn't it? It's easy to look at someone that and say that stuff. Yeah. But it's not so easy to do it with a world, is it? Yeah. With yourselves. Because superiority and loyalty only goes that way down there. It doesn't respond to look at yourself, does it? And then if we're acting like this, are we manifesting a reality or a future from others? Then it's a question of who's more advanced. And then their time is their attention, and when did they pay attention to then look at that capability time to do something about that or counteract? And then they would know how to maneuver depending on whether they are, how many star systems they've jumped. They would have a lot more knowledge of how to counteract themselves and then put onto land creatures. And then, if you can see that far back in time, resurrection is in 3 ways. One is you stay alive as a species and keep going, covering your tracks, which is another one. Is other species finding remnants of you and can rebuild you and bring you back, depending on how far their technology went, by looking into the light. Yeah, that's a hell of a capability, but even still, if they were tracking it all down. And the third is the most protected. Oh, it's inwards. It's in you. The mighty high. The divine, spiritual, your ancestors, the ones that made it. That can shield you from ever being resurrected here. That's the overall protection then, isn't it? That's also eternal life. Protected, eternal life. Because it holds a key. Some keys are more precious depending on what they lock. And some other keys you can toss away. How many keys have you thrown away in your life? Lots? It all depends on what key is unlocking what. Then that key might become valuable. Bank key. Very valuable, you would say, wouldn't you, in modern understanding? A safe key, very valuable. What about a key that locks a book? Not very valuable, is it? Well, it depends on the information inside there, I dare say, but even still. Meh, whatever. Well, it's easy to bust that lock, really, isn't it? And not really care. Not really do much to encrypt it either, because you know it's just a fucking diary. So, three. And do you ever think this looks like the Egyptian eye?
Yeah.
Is that a yes or a no? Like,
Yeah, I said yeah.
interesting shape, isn't it?
Yeah.
6. It's like the Egyptian eye, doesn't it? Anyway, right, let's leave it there, and that's where I'm going to leave it for today, I think, for this one.
Okay.
I'd like to go on to the other one, but maybe in a bit, maybe not. Maybe tomorrow. Who knows?
Okay. Yeah.